Hey guys, so far we have finished two chapters in our syllabus, and that is the first and second chapters. That will be matter around us and motion. So with motion we also engaged with some sums that we did, and I hope you understood the topic in general, because this chapter is a continuation of our second chapter, motion. Okay, so the third chapter is laws of motion. Now to speak about motion, we know what motion is from what we have studied, but if you think about it, back then, long ago, people didn't have these books, right? All of this was written by people, by observing and understanding. So before we knew everything, there was a lot of debate, discussion about what is right, what is wrong, how exactly it works, things like this, right? So majorly there's a guy named Aristotle, a physician, a philosopher. He had his own theories about motion. There was Galileo, who had his own theories about motion. Galileo, you must have heard his name in other places too. So he had his own theories driven through his own experiments, and there was in general disagreement among the different scientists who were working on this topic. Finally, there was just one person, Newton, who looked at everyone's experiments and tried to understand things in the best way he could. And from what he did, from his work, we have something called the Newton's laws of motion. Okay, so Newton tells us about motion in three different laws. Any body in the universe that is moving or follows motion definitely follows these three laws. So for the next few days we'll be going through these three laws, understanding what they mean, and how we can go about either proving them or understanding them. Alright, excellent. So today we will start with the first law of motion, that is Newton's first law of motion. And to state it, generally when we write laws of motion, we write them word to word. Okay, now don't but there's always a difference between what I say or anyone else says, what it says in your reader, what it says in someone else's reader. There's always a difference, but in general the idea behind the law is the same. Okay, the law states something like this: every body will remain in a state of rest or in a state of uniform motion unless acted upon by an external force to change its state. Okay, it's a big long sentence, but let's break it down. Every object, basically everything that moves, will remain in rest or state of uniform motion. Basically, if an object is at rest, it will stay at rest. If it is moving, it will keep moving. Unless acted upon by an external force, unless something from the outside is forcing that object to change upon an external force to change its state of motion. Meaning, if there is an object at rest, unless something puts some force on it to move it, it will stay at rest. If something is moving, unless something tries to stop it, it will not stop. That is what this law states. Okay, try to remember the sentence as it is. That's a generally asked question. So to understand this first law, we will be performing one very small activity. Through this activity, maybe you will get some clarity upon what I am trying to tell over here. Okay, so for this activity, I have this glass beaker here that I have filled with water. I took it glass because so that you can see what's happening, right? Maybe I'll turn this around so it's clearer. All right. Along with this beaker, I have a coin, right? A usual coin, and I got just this card. Anything can do, any thick paper also is fine. You can try this yourselves at home. Okay. Now notice that I have three objects with me. I have this glass, I have this card and this coin. So I'll place them one on top of the other. Okay. I put the card on the glass and I put the coin on the card. Okay. Now notice, all three objects, are they moving or no? They are not, right? They are in a state of rest. None of these three things are moving, and they will stay like that unless something forces one of them to move or all of them to move. For example, if I take this and I just lift it, right? I'm using some force to move this object around, and along with it everything else, right? Okay, now what I'm going to do, this is probably something you've already tried and seen others do, right? Something we do for fun. This coin is on top of this card is on top of this glass. I am going to move this card quickly. All right, I'm going to use some force to move this card. Okay, right now the card is not moving. I'll use some force to make it move. Okay. Now watch what happens to the coin. Pretty sure you already know, but let's see. All right, so the coin is here, card is here, and now the card that I hit has flown all the way across the room, but the coin that was on the top, it didn't go along with the card. Although it was on the card, it didn't go along with the card, right? It stayed in the same place and just dropped down straight. Alright, why did this happen? The card moved but the coin did not. It is simply because the force that I was using was only on the card. I did not put any force on the coin. That is why the coin, it stayed at rest itself, and the card, since it was acted by a force, it moved. Same with the glass. I didn't put any force on the glass, so the glass stayed, the coin stayed, and since the card was no longer there to support the coin, it fell right in the glass. As simple as that, right? So generally this law tells this. Okay, I hope you understood what I'm trying to state over here. We call this property of objects as inertia. Okay, so this law, first law, is also called as the law of inertia. Now inertia is nothing but some objects tend to stay at rest. Okay, they tend to stay at rest, and some objects will tend to stay in motion. Again, that depends on the object itself. So the reluctance of an object to change its state is called as inertia. A simple example I can give you with inertia is this. If you ever traveled in a bus, right? So you're standing in a bus, the bus is moving, suddenly it stops, right? You'll feel like the top half of your body just goes forward, right? That happens because until the bus was moving, your body was moving along with the bus. But suddenly when it stopped, your body didn't know, because the force didn't act on your body, it acted on the bus, which is why your body tried to keep going in the forward direction, but the bottom half of your body stayed there because it's in touch with the bus. Similarly, whenever a bus is just stationary and suddenly it goes off, you feel like you're falling back, right? That's because your body is in a state of rest. It didn't realize yet that someone's trying to move it. So that reluctance that comes, that is inertia. Very simple real life example of inertia that we have. So this is all that I will tell for today. Let's recap. We knew Newton made 3 laws, out of which we have seen the first law, right? We'll make sure we have that sentence ready with us. Okay, in your notes, make sure you write it down. If you want to refer to the reader, that will be great. It's the chapter number 3. Okay, be on the second page of your chapter. Along with that, we saw a small activity to understand how inertia works, or this reluctance to move works, with this coin and car trick. You can feel free to try it out at home. And we also just looked at the definition of what inertia is, some real life examples where we see inertia happening in daily life, right? So this is all for today. Tomorrow we'll study a little bit more about inertia, maybe see some different activities that involve inertia. If possible, we'll also go to the next, second and third laws. Okay, all right, excellent. So this is all for today. Thank you. I hope you come tomorrow. Bye bye.